solving day 10 advent of code. Let's start. Pipe maze. We are given some 2D matrix of characters, starting position, ground. These are all blends, vertical, horizontal pipes based on the acoustics of the animals. You're confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of pipe. Okay. If the animal had entered this loop in the northwest corner of the sketch would look like this. The above diagram style is still 90-degree. You can tell because of the that's connected to it. Fortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. Which comes in the main loop. The pipes those pipes connect to and so on. Okay. You're going to get out ahead of the animal. You should find the tile in the loop that is farthest from the starting position. Because the animal is in pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to from the starting point, regarding of which way the loop will went. For example, you can count the distance in the tile as this. In this example, the farthest person is 4 steps away. Find a single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Looks very large. So this is the input. Or even it could be like this. It's fine, we can find. I hope there is only one cycle in this, because if there are multiple, then it would be very difficult to find out the largest one, because let's see if the question mentions anything about that. Okay, based on the acoustics of the animal scurrying, you're confident the pipe contains the animal is one large continuous loop. It is one large And fine, so what we can do is, first of all, we need to add edges like these. So S will have a right and down edge, 7 will have left and down, J will have left and up, L will have up and right. And if they are present, there is a pipe next to it with S. Are we given S in the input as well? Wait, there were. Okay, S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape that pipe has. Okay. So this S shape can have any pipe below it. So say for example it was this. Basically we can try for all of them, all 4 of them, and check which one gives us which one finds a loop, and that would be the pipe which is below S. One decimal joint loop starting at S. This loop. Once we add the edges, then what we can do? Horizontal. We have these types, 6 types, and S is also there, so we'll replace S with any of these 6 and then create a new grid, and then check whether it contains a large continuous loop. Okay, let me think how we can find a cycle in this. Would DFS be sufficient? Since this would create like an undirected graph, and you only need to know the distances from the starting point, right? So I don't think it is even necessary to find out the entire graph as such, but we can mm, we can start a BFS from S and keep track of visited nodes and the distance. And start here. There would be some character here. Then we will check depending on what character it is, whether lies in a loop. Since it will always be a one giant loop, right? So let's see this question. The extra non-main loop pipes are also shown. Non-main loop pipes are also there. Okay, fine. How do we cope up with that? So these one right here. So J will be like this. Okay. 7. I mean, once a character is in the main loop, then it won't be a part of any other sequence of pipes, which would be like a linear path of a graph. So let's say this J is adjacent to 7 and this hyphen, then it cannot be joined with this thing. So there is a one main loop which starts at this, then since they have mentioned that start is always part of a loop, and once you fix a start, then there would be like, but start can also have a vertical pipe, horizontal. Pipe on this style, but sketch doesn't show what shape it has. Fine, it can be one of these 6, and once we initialize that, we need to check all of the adjacent, 2 of the adjacent pipes of that current starting point, and that would give us 2 options for the BFS traversal. So starting will have distance 0, their adjacent would have distance 1, and so on, in breadth first search manner. So yeah, that's what I would do. Regarding the implementation, I can keep track of for each of these pipe types what are their adjacent elements. Like suppose this is I comma j in this matrix, then the adjacent ones are the one above and below it. So that would be I minus 1j and I plus 1j, like so on. Okay. Let us try implementing this. Answer for this is 8. Then For this it was 4. Now I need to take input. I need a vector of string matrix string line while scene line pushback line. I hope all of them have the same this thing line characters. So mat dot size and n is mat dot size. Fine. This would be the input. Then there would be some starting and ending. Let's say si sj 0 if line of this row of j is a starting, then si is row, si is row, sj is j, and row plus plus. It. Then we know the starting position, and we can basically try all of them. Before that, let me initialize this map of character to, what should I do? Let's say array of int4 maybe adjacents. Let's initialize them. Which would be something like this. Adj of one, two, three, four, five, six. Vertical. So what needs to be subtracted from let's do it like this. So it would be array of int 2 of 2. Is that fine? Okay. So minus 1 0 and plus 1 0. Does that make sense? I don't think so. State vector of int, or should I just make it simpler? Is it fine? So the first one is the first two values are the first two adjacents. Let me make it array only. Hope this works fine. Okay. So this one is dx1, dy1, dx2, dy2. Okay, now for the 6 of them, for this the row remains same, column changes. Next we have L. So L is the LJ7. L is like above, so -1 0, and right, which is 0 plus 1, -1 0, and 0 plus 1, fine. J is, sorry, it is above, and left is 0 -1. So above and right, and above and left. 7 is left, that's this thing, and down, which is right, this is right, and F is down, so this for down, and for right it would be 0 and plus 1. This is above right, and this is down and right. Fine, let's hope this is correct, otherwise we won't get expected answer. After that, you want to start at this, and depending on what is the starting position, so let's try for all of them. Let's say const string chars this J7F. Put as a starting point, so this, we will create a new matrix copy of that matrix. Let's say new mat is mat, and we'll put SISJ as this value, and then we will find out if this matches with what we are actually inserting. So here what I wanted to do is, the adjacent for this would be dx1 dy1 dx2 dy2 is equals to, what was that matrix adjacent, adj of put, right? And there there could be multiple possibilities here, right? Why don't I just figure this out for particular input, right? So for in this test case, we must have been given some starting, and this will be Since this is a vertical, this should not match, but this should match. So S is a vertical here. That is because it will not match with J. It will not match with this F. So F is like this, and S should be a vertical pipe in this case. Fine. I mean, I can hardcode this based on the input, but this J is F. I mean, whatever character we put here, we also need to check what all adjacent coordinates are present for that particular character, and for those adjacent characters we also need to check whether this direction is allowed. So this J will give coordinates of the up and left, and this vertical will give coordinates of up and down. Hence we need to check the adjacent characters of this as matches, one of them matches with the adjacent character of this, and the same for this other one. So let's say I do this, and then say we run this function, which would be vector of string, say A. Now SISJ, and I need to know the starting points. It has been inserted there. We are currently here, and we have, let's say, inserted a F here. Then U of pair of int, since we are performing BFS. Push SISJ. Distance for SISJ would be 0. Vector of ints, distance, and vector of int, and let's say large value. Then while q is not empty, ci is the current, CICJ is the current value that we need to process. We remove it from the queue. Then the adjacent values for this particular cell would be, let's first find out what was the, wait, so I want this would be adjacent value of E of CICJ, right? And the adjacent coordinates would be something like the two neighboring cells would be, let's say, Ni1 equals to Ci plus Dx1, and Nj1 would be Cj plus Dy1, and this would be this R2, right? So we find out the two neighboring cells of CICJ, and let me do one thing. Let's create CI neighbors, get neighbors CICJ, and neighbors N1 neighbors and N2 neighbors. This would be N1, Ni1 and Nj1. I2, G2. So this would give us, so basically C neighbors essentially contains these two values only, but we are doing it so that that would be vector of ints j. I also need to know that this is a valid character among the 6 pipes. So character would be, it should be, let's pass in the character as well. Let's pass A, I think. Need to assert that dot con this character is getting 0, and then Here we will do the same thing. I want to do this. These are the designs of them, and the coordinates would be like this. I need to NI1 and NG. Like this. I'm not considering the outside of the matrix case, but let's hope this would work. Now the condition to go from this to these two would be that um so current cell has neighbors C neighbors, N1 has neighbors, let's say F and S, then uh, N2 has these neighbors S and L. Now we need to check. I don't think we needed to find out the neighbors of this thing, but it's fine. It's fine, I guess. We check whether N1's neighbor contains CICJ and N2's neighbor contains CICJ. Contains or find? How is it? I hope this is a vector of and one neighbors dot count. I think it should be count all N1 neighbors, and what we need to count CICJ, and count all N2 neighbors for CICJ. If we get that, count is not present. Well, this cannot work. Okay. Then these two are the and we need to take the distance and add them in the queue. If distance of an I1 J1 is greater than distance of CICJ plus 1, and add them in the queue. Similar for the second. Perfect. And after all this is done, let's also print the distance matrix. And I have kept all of this zero based, so hope that's not an issue. I hope there are no any intermediate issues. And we also need to give the maximum, right? It would be this thing. And we have the inputs. Let's try running. At least this distance should have been 0. Is that the case? Yes, it is 0. That's fine. But these must not have been updated, right? So let's check the condition for checking adjacent. If this is correct, then we remove it from the queue. We find these two neighbors, then we find I don't think it is entering this case. So let's try printing what these values are. And this as well. I think I know what I've missed, so I have initialized this but not called that function. And I think this should have failed as well, right? If it would have. This count should have failed or not. I think it should have failed, but why didn't it fail? Uh, Other than these, what characters would it be on? It should be on a dot, but how do we handle a dot? We can. But the thing is, don't want to go over a dot right anytime. So if it's a dot, any of them. So let's say the first time when we are actually calling this, let's do it here. If any of this is outside, let's say not inside, N1, NI1, NJ1. This would not happen, but still let's write it anyways. Or this is a dot. Or this is a dot. So I2, NJ2, dot, then continue. And let's write inside boolean inside j, then I is greater than equals to 0, I less than n, j is greater than equals to 0, j is less than m. Let's try it now. Still fine, the answer is getting updated, but I mean, why did it print so many times? Okay, we have six possible values to substitute for the starting position, right? So 1, 2, 3. I think it's more or less. Since we are finding out maximum here, it will always be, let's do it like this. If distance of ij is less than 1, 9, take the maximum in that case. Distance 4. 4 is correct for this. And it is correct for this, I hope. Yes. Let's remove, or let's try the last test case immediately. Test, paste, save, solve on test. 0. Wow. Fine, we got the right answer for this. So basically, we have been trying 6 possible combinations for the starting position, right? And for only one of them, the answer would, I mean, that would be a valid large loop as per the constraint in the question. So for all of them, I found out that all of them were 0, and only one is a valid answer. So let's change the code and do it like this. This would return me the maximum answer. Let's say return answer from here, and I will take the best from the return value of this, like this. And what's the issue? Okay, fine. Change this to int. Then the final answer would be best here. One more error. No. Let's run it on samples, and yeah, you can check that. We got 2 test cases correct, I guess. Let's load our test. Should give us 6717. Perfect. And on in 18244. Copy. So let's copy. So part 1.cpp. Part 2. You quickly reach the farthest point in the loop. Then whenever images its nest is within the area enclosed by the loop. to determine whether it's even worth risk. What taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Okay. The above loop encloses merely 4 tiles. The two pairs are dot in the southwest, and southeast, marked I below. Okay, are not in the loop. Here is the same loop again with those regions marked. These regions don't count in the loop. So this is one giant cycle, and we need to count the number of nodes in them. In fact, there doesn't even need to be a full tile path to the outside. For tiles to count as outside the loop, squeezing between pipes is also allowed. Here I is still within the loop and O is still outside the loop. What the fuck? In both of the above examples, 4 tiles are enclosed by the loop. There is a larger example. This cycle will give us a connected component region in the graph or in the grid, and then in that region we need to check how many dots are there. I still no slots at the loop. Fine. In both of the above examples, 4 tiles are enclosed by the loop. Here is a larger example. Any tile that isn't part of the main loop can count as being closed by the loop. Here is another example of many bits of jump pipe. Here are just the tiles that are included. In the last example, to count right. So using the solution for part 1, we can find out the cells which contribute to this cycle, this loop. But after that, to find out what all elements lie inside them, I think one thing that I can do is, let's start a DFS from this starting. Let's say we have the coordinates of these, right? So we have the coordinates for this S7G, all the hyphens and the verticals. We have those coordinates, then we can there can be multiple regions of these dots as well. See this one side. So these 5, 6, 7 and 8. Mm-hmm. What I can do is for the corner cells, it is obvious that we can have for J, L, 7 and F, we know that it is a right angle that it forms, right? So it is a corner of some loop. But for vertical and hyphens, we don't know whether to take whether the loop contains this or the opposite side to it. So for this vertical, the enclosed cells could be on the left or the right. And but instead of that, why don't we just find out? We can count all the dots in the grid and then subtract the dots that are outside. But this case would still make it wrong, because if we start DFS at any of these points, let's say we stop somewhere. How is that going to help? We have some of the corners, and on those corners we can find out what should be the diagonal cell which lies inside the loop. So if it is a F, we know that it connects to the right and the bottom cell, but its diagonally right bottom cell is what? No, but that is not correct in this case. So if I say that F has this inside the loop, then it is not correct, because this lies outside the loop. Mhm. Enclosed. I think there was a similar question on lead code for this. I'll try searching for some similar problems on the code. Single of zeros and number of closed islands. But we saw here, right? Even if a particular cell is surrounded by all of these, it still is outside the loop. Let me first understand the question is what you want. Mm-hmm. Even about a certain how to define if such a concept. Okay. Determine the smallest rectangle enclosing the area but sharing no cells with the area. Point B, we should determine if it's outside the area as unvisited. There are no cells marked as unvisited. B is inside the area. If it is inside, this yellow borders are the rectangular boundary of our loop. Hectic considered, so that case. This is inside the loop. We are going to go and visit everything else. But this is for convex cases only, right? Or not? No. Okay, example 3 will take care of that. There are no cells marked as unvisited. P is inside the area. This example, the point P is outside the area. But again, this is not like an area thing. I mean, we want to count these cells and this case is how do we figure out this case? Say we do the same thing here. But there is no escape for this, right? So I mean, if he is considering it in terms of, I mean, though there is no direction constraint here, right? So this question is not relevant to us. Okay, what else? We can count this outside the region dots without any issue. So we can find out, let's say, I mean, if there is a if I find a dot, then traversing it everywhere. Let's try to draw something. If the region was something like this, could be anything, right? So there is no, so there is nothing here. In that case, that would still be inside the loop. The only time when this fails is, say, so everything here is outside, and there can be multiple of these locations. So say something like this occurs. This is also outside. There can even be complex shapes in here. So say a similar shape here like this. Okay. Think I need more time to solve this. I can try it later. If we do one thing, if we, for all the corners, we start this, but this would still fail for this one, right? Because it is not inside. Or we can say, but even the cells that are inside don't form a single connected component. Okay. If we treat all of these as one entity, and that means basically we find out these cell coordinates, these, then these, Let's say the elements in the loop are denoted by star, all of them. Hence, this would be star, 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 star. Now we will have to find out, but again, how will we know that this is outside? Fine, I'll get back to this later.